Welcome to Autocad. Today, your life is going to change. Autocad can have a huge impact on your future. What exactly is Autocad? Autocad is used to create computer-aided designs or software applications including drafting. Autocad develops the application in both the 2D and 3D formats. In this course, we will only be working in 2D formats. It provides the information to the application through the program. AutoCAD is used to create the computer-aided designs or software applications included in drafting. So what is technical drafting? Technical drafting is the act and discipline of composing drawings that visually communicate how something functions or how it is constructed. Technical drawing is essential for communicating our ideas in industry and engineering. We also have architectural drawing. Again, we won't be covering a lot of that in here, but we will do a little bit, and I will point out some things that are different between technical drafting and architectural drafting. Who uses AutoCAD? AutoCAD is used by architects, engineers, interior designers, real estate developers, artists. The list goes on and on. Over the years, AutoCAD has built a substantial army of users with over 20 different pieces of software being offered in its suite. It is a huge program. We are barely going to touch the program itself. But after you finish this course, you are capable of getting a beginning AutoCAD job. So let's get started. The first thing is we have to understand how AutoCAD thinks. AutoCAD is based around coordinates in the Cartesian coordinate system. You may have heard that terminology before, probably back in like 3rd or 4th grade. That's typically when you learn about the Cartesian coordinate system. It may not have been identified in that name, but that is what it is. In the Cartesian coordinate system, points are located using 3 coordinate axes. The x-axis, which is horizontal, the y-axis, which is vertical, and the z-axis, which is the 3-dimension. So every point in the coordinate system has 3 coordinates, the x, y, and the z. In our 2D drawing, we don't use the z-axis, but it is part of the coordinate system, so don't forget that. We are only going to be working in the x and y coordinates. So let's look at the Cartesian coordinate system. This may look familiar to you. In the center of our coordinate system, the x and the y are both 0. Anything that is in this quadrant is going to be a positive x and a positive y. X being in this direction, y being, in this direction. Everything that's in this quadrant will have a positive x, but will have a negative y. Everything that is in this quadrant will have a negative x and a negative y. Everything in this quadrant will have a negative x and a positive y. So we can identify every point in our coordinate system by an x and a y. If I take this point and I place it over here, you will see I have a positive x, comma, positive y. If I place it in this quadrant, again, I have a positive x, but a negative y. If I place it in this quadrant, both the x and the y are negative. If I place it in this quadrant, my x is negative, but my y is positive. This type of point, no matter where it's at in our coordinate system, is called an absolute point. Absolute points are exactly what they say. It is absolutely that point. That point can never change. If I move it over to here and I put it close here, basically wherever this point lands, that is always and forever that point. Again, those are called absolute points. Sometimes we don't always know an exact point or our absolute point to where we can just enter 2 coordinates and then go to the next 2 coordinates, etc. Drawing doesn't typically work that way. So we can use another type of point that is called a relative point. Relative coordinates define a location in relation to a previous point. If you look at the example, you'll see if we start in the center of our graph or our coordinate system and start with a point there. On the right hand side, that would be indicated by point 1. We may not know the exact absolute point of point 2, but we know it is 6 units in the x direction, positive, and it is positive 6 units in the y direction. So we can tell Autocad we want to start from a certain point. We don't know what an absolute point is next, but we know a point in relation to that. With my absolute point in Autocad, I just have to put in the x coordinate, comma, y coordinate. When I get ready to do a relative point, I have to add something to my command line so that Autocad knows that it's a relative point versus a absolute point. So we use the at symbol. So we will still do our x and our y, but we will say at or in relation to x, comma, y. There is one other coordinate system that we need to talk about, and that is the polar coordinate system. We don't always draw everything horizontally and vertically. We can draw angled lines by using our reference coordinates from an absolute point or an absolute point to an absolute point, but sometimes that's not the information we're giving. Sometimes we're told how long a line needs to be and at what angle it needs to be. So to be able to do that, we have to use our polar coordinates. Again, this is something you probably learned back in elementary school years. On the coordinate system you see in front of you, to the far right, horizontally, is 0. If we go up and to the left, we have 90 degrees. If we continue on to the left and down, we have 180 degrees. Then if we continue on down to the right, we have 270 degrees. Then we end up back at 0. We can also use these numbers negatively. As long as I use the negative sign, I can use my angles going in the opposite direction. Again, this is a type of relative point. So we are going to use the at symbol again when we talk about this. We are going to have to also explain to Autocad what we are trying to do. So in this particular case, we're going to use a different input method to be able to tell Autocad that we are actually using a polar coordinate. We will start the command again with the at symbol because it's going to be in relation to another point. And then we say the distance or the length of the line. For example, if it's 35, we would put at 35, and then to represent that we are talking about an angle, we are going to use the less than sign. So we would say at 35 less than, and then we tell it what angle. We always work in a counter counterclockwise direction. So wherever my point is, and I want to go to the next point, I work off a 0. So if my angle from 0 in the very, very center at 0, 0 is pointing down into the bottom left quadrant, I'm going to come off a 0. So my number will be somewhere between 180 and 270. So I would say at the distance of the line or the length of the line less than the angle from between 180 and 270. When we get to drawing, hopefully this will make more sense. But polar coordinates are another way for us to tell AutoCAD how to draw. While we are on the topic of learning how AutoCAD thinks, we need to talk about units. When we actually get into the program, we can set different types of units depending on what type of drawings we're going to do. If we're doing architectural drawings, we would set it to an architectural unit. If we were doing decimal drawings, we would set it to decimal units. It's important, though, to understand how, from an architectural standpoint, you have to input information. When you're working in decimals, typically on your mechanical type drawings, this really doesn't come into play as much, but there are times when you do have to do architectural units. So if I were hand drawing a drawing, or I was putting in some information, if I were to write the dimension of 1 foot 2.5 inches, the top line would be how I would write it. I would write 1 with the foot mark, then I would have my dash, and then I would have 2, then I would leave a space, and then I'd put 1/2 inches. In AutoCAD, for that very same dimension, I would actually put it in differently. AutoCAD thinks in full feet, full inches, and then partial inches. So to be able to tell AutoCAD that, when I put in my 1 foot, I do that just like I was if I were handwriting it out. But then I don't put the dash. I go directly to the full inch. So I do 1, the foot mark, 2, and then once I finish 2, I have to tell it, okay, now I'm going to give you the partial inch. So then I put the dash in and my 1/2. So you basically reverse the 2 and the dash, and there's no space. So that's very, very important. If you try to put it in like you would typically write it, it's just going to keep not doing it for you and asking you for the point over and over and over again. The other thing to remember is that AutoCAD thinks in inches. So if I put in 12 and I don't put the foot or inch mark, it's going to assume I mean 12 inches. If I want it to be 12 feet, I have to put in 12 and the foot mark. The foot mark is the apostrophe, and the inch mark is the double apostrophe. If I am doing decimals, I can put in 1/2 as 0.5. So another possibility in this would be I could put in 1, the foot mark, 2.5. And I don't have to put the inch marks on the end of that because it knows that that is inches. You will see me typically always put the foot and the inch marks. That's because Revit, which is the other architectural program that I use, thinks in feet and not inches. So instead of me having to stop and think every time of which program I'm in, I always typically put in my feet and inches. But what you will learn is the whole idea behind AutoCAD, besides learning how to use the program, is to be efficient. To be efficient, we have to be accurate and we need to be fast. So by eliminating steps, you think, well, putting in the inch mark doesn't take that long. If you do that 50 times a day, that adds up to time. So the idea is to get as quick at AutoCAD as you can, but also be correct and make sure you're doing things in the correct manner. There's a fine line between efficiency and accuracy. So you have to learn to do that. One of my favorite sayings is, time is money. So the faster I am at doing things, the better I'm going to be at my job and the happier my boss is going to be. Typically, most of the businesses you're going to work for, they're in the business to make money. So if you can help make them money, you are going to be an asset to their company. We have one more thing to cover before we actually get into AutoCAD, and that is the subject of file management. File management is important, especially in drafting. It helps you to save time and helps everyone to work more efficiently and smoothly. Remember what we just talked about? Time is money. The basic objective of a good filing system is to be able to find your drawings and other documents that you or someone else needs quickly. The goal of a good filing system is to provide quick access to information. How does this happen? One is how you name the files. They need to make sense. Two is where they are located and how they are set up. As you can see on the screen, this particular company has a process for filing their projects or their product. They have their main folder, which is their quality management system. Underneath that, they have documents. Under that, there are probably particular types of documents that go into that folder, and those are going to be categorized underneath that. Procedures, production, machining, CNC, work instructions, safety, risk assessments. And under that, you see they again have some additional folders. We are going to set up our system for your filing of your drawings and files along the same lines. Again, it's important for you to be able to find your files, but if I need to get into your OneDrive to pull a file, it's important for me to be able to find them. So let's take a look at how we are going to set up our systems. We went through this a little bit on the first day of class, but again, you need to go to your OneDrive. Again, you can use portal.office.com, or in your email, you can go to these little dots up here in the corner and click on that and go to your OneDrive. I'm going to ask that once you're in that, you create a new folder, and I would like for you to name it DDT 100 and then your name. Right here is the folder that I just created. Once you create that, you'll see over to the right a little corner of a paper with an arrow. If you click on that, it is going to allow you to share that folder with me. So you will just start typing in my name and my email should come up automatically. All you have to do is hit send. It will send me the link to that. For your assignment today, you're going to go into this folder, and anything you create within this folder, you do not need to share with me because the whole folder is shared with me. As I mentioned the other day, don't put things in here you don't want me to see. Not that I'm going to be snooping through it, but in most cases, I may never come to your folder other than on this first assignment because I want to make sure you set things up correctly. But it's going to be important for you to keep everything organized. We're going to do a lot of assignments in here. So you're going to have several folders. If you just start dropping files in here, it's going to be a mess. So the first thing we need to do is up here at the top, we're going to create a folder for your assignment that you're going to do today. And you're going to click on folder, and the name of this folder is going to be 01 with a dash and then file management. And that is exactly what you're going to do today. Every assignment from here on, you're going to create a new folder. So for example, the next assignment you come to, and I don't remember exactly what it is, but it's going to say 02 and then whatever the name of the assignment is. So now you'll be seeing a list of folders in order, which will help you to be able to find what you're looking for. when you get ready to do your assignment today, the CAD portion of it, you want to make sure that you're saving the files within the file management folder, not out in your main folder. When you get into your main folder, you should only see files. You should not see any AutoCAD drawings or backup files or anything like that. Everything should be saved under here. I hope that is pretty clear. We will talk about that more when we actually get into the assignment. Next, we are finally on to AutoCAD.